Hello, in this video, we will introduce sequence containers. We'll take a look in depth on sequence containers. A sequence container maintains the order of the elements in the container. It has the notion of index. The STL provides three sequence containers: vector, list, and deck. The vector and deck containers are implemented using arrays, and the list container is implemented using a linked list. It's actually a doubly linked list. A vector is efficient if the elements are appended to the vector, but it's expensive to insert and delete elements anywhere except at the end of the vector. A deck is like a vector, but it's efficient for insertion at both the front and end of a deck. Nevertheless, it's still expensive to insert and delete elements in the middle of a deck. A list is good for applications that require frequent insertion and deletion anywhere in a list using an iterator. A vector has the least overhead. A deck has slightly more overhead than a vector, and a list has the most overhead. The common functions in sequence containers are defined in table 22.6. Assign n copy of specified element in the container. Assign the elements in the range from iterator begin and end. This is the pushback at an element in the container. Pop back removes the last element from the container. Front returns the first element in the container. Back returns the last element in the container. Insert position element inserts the element at the specified position iterator. So this insert is efficient. You are using this position here for the list. It's efficient, but it's not efficient for the vector and deck. Sequence container. Now, let's look at a vector. These are the functions specific in vector. Vector n element. Construct a vector filled with n copies of the same element. Vector begin end. Construct a vector initialized with elements from iterator begin to end. So please note that this is actually, it's end minus one because begin end means it's past the iterator. And the real one is end minus one. Vector size constructs a vector with the specified size at index, returns the element at the specified index. Please also note that for the vectors, you can use the subscript operator. So rather than using at index, you can use vector brackets index. This is the demo right here using vector. We have this array of double elements. Now we create a double vector from this array values, that is this right here, the pointer to the first one, and +7 is here, is the past the end. So the real one is the 7. The initial contents now is displayed. So we are writing this is all the way into the end. So you can put this as this just 7 here. So we're going to display it using index. Double vector, we're going to assign this value 4 times. So this is displayed now. And so this is to assign 22.4 to this. This is the function at that is actually returned by reference function. So you can assign this value to this. It's the same as writing the brackets index right here. So this is to display the result now. So here is get the iterator. So we use auto now. Double vector dot begin. So now we're going to insert here, insert at this location with this value, and insert another one at this location. So with another value. Display it. And this is the erase. So we're going to delete the elements using iterator. And now delete all. So delete all is, you can use that clear to delete all. So this is to see if it's now empty, true or false. Now let's look at the example for the deck. So here are the functions specific in deck. So this is deck, this is the constructor. You construct the deck with filled with n elements, deck using begin end, the iterator, deck with the size and using at. So this is the push front, here, pop front. So this is the test program. Here's the deck. We construct the deck from the array, and this is to display the elements in the deck. So now this is assign, and this is to have this deck. This is double deck dot at 0. You're going to assign 22.4 here. So please read this example. Let's look at the list. So these are the functions specific in list. So here's list, an element, construct the list filled with n copies of the same element, list the begin end, list the size, push element, pop front here, remove if, remove all the elements for which this is the Boolean function is true. So this slides. So this is the in C++, you can pass function parameters. So we're going to talk about this more in the next chapter. Slice, you can get the slice from the list. So this is sort, merge, and merge to sorted lists. So you can do that using this merge and reverse. So here's an example of using all these methods, using these functions in the list class. That is all for this section on the sequence containers. See you on the next video.